Hey guys, welcome back to the channel Code with AKJ. Today's question is Kadane's algorithm. This question is being asked in many interviews. As you can see, the tags are here is more than 22. So it's been asked in more than 22 companies. So let's see the question here. So the question says, given an integer array ARR, find the contiguous subarray containing at least one number that has the maximum sum and return its sum. So the given example here is array 1, 2, 3, minus 2, 5. So the maximum subarray sum would be 9, considering the array 1, 2, 3, minus 2 and 5. Coming to this example, here the maximum sum would be minus 1 as a single element itself, as single element is also considered as a subarray. And in this example, the maximum subarray would be 5, 4, 7, the whole array. So we need to find a subarray sum which would be maximum among all these per element. So let's analyze these examples and find out a brute force approach. So the brute force approach here would be to consider all the subarrays of a given array, and we'll find out the sum of all the subarrays and we'll take the maximum out of it. So I have here written few subarrays of this given array. The subarrays here would be 1, 2, 3, minus 2, 5, the whole array itself, and I have considered all the single elements also. I've written few other subarrays also, and we'll consider the sum of all these subarrays and we'll take the maximum out of it and we'll return the value. So let's code this approach and we'll see whether it gets submitted or not, and we'll also find out the time complexity and space complexity of this approach. So this is the brute force approach code. Here I have generated all the particular subarrays and calculated the subarray sum of each and every subarray, and I have taken the maximum of all it, and I've taken the best sum out of all the subarray sum, and finally returned the best sum. Here the code goes like this. I have iterated the value from the first element, and I've taken the j value starting from the first element itself, and I've taken the k value which generally runs from I to j and calculates the subarray sum. So let's understand this code with this example. Here I runs from 1, j runs from 1, and k runs from 1. So since k runs from I to j, here I is pointing at 1 and j is pointing at 1, so the subarray would be 1 and the sum would be 1. In the same way, j moves from 1 to 2, so here subarray would become 1, 2 and sum becomes 3. So in the same way, we'll find all the sums and we'll take the maximum of it and we'll return this value. So let's submit this code. As you can see, it gives time limit exceeded. So the time complexity here would be O of n cube, as we are running 3 for loops, and space complexity would be O of 1. We need to optimize this approach and convert the time complexity from O of n cube to O of n as expected given by the problem statement. So the optimized approach for this would be to take two variables, current sum and best sum. Current sum would be 0 initially and best sum would be int min, as we need the maximum value. So initially we have initialized with the least value possible for an integer. So we'll calculate the current sum parallelly and compare it with the best sum. So initially current sum would be at the first index, the current sum would be 1, and the best sum would be the maximum of the initial value and the current sum value. So here in this case it would be 1. So current sum moves from one index to another index. Here current sum would be 1 plus 2, that would be 3, and we'll compare the best sum with the current sum. Here the maximum out of 1 and 3 would be 3, so the best sum updates to 3. The same way we'll calculate all the sums parallelly, and current sum would be 6 here and maximum best sum would be 6 here, and current sum moves from 3 to minus 2. Here current sum would become 4, and here best sum would be 6 itself, as the maximum out of 4 and 6 is 6. And finally current sum moves from minus 2 to 5, and the current sum would be 9. So the best sum would be the maximum of 6 of 9. So finally our answer would be 9. So in this way we can optimize the approach using a single for loop, calculating current sum parallelly and comparing it with best sum. So let's code this approach and let's see whether it gets submitted or not. So this is the code for the optimized approach we have discussed through the diagram. So here I have taken the size of an array in value n, and I've taken two variables, current sum and best sum. So I've iterated through the array and being calculating current sum parallelly, and along with that comparing it with best sum. So this would be the main case, defining case, where if at any point the current sum becomes negative, we'll reset that current sum to 0, as we don't need a negative value in our current sum, which will make our final sum more negative. So in this way, we'll calculate the current sum and we'll be updating the best sum parallelly. So finally, after completing this for loop, we'll get a best sum, which would be the maximum subarray sum from the given array, and we'll return this value from the main function. So let's compile and run this. So let's submit. As you can see, this problem got solved successfully, and here the time complexity would be O of n, as we are using a single for loop, and the space complexity would be O of 1, as we are not using any extra data structure here. So we have solved this particular problem in our expected time complexity and space complexity. So this is it, guys. It was a great question. It's been asked in many interviews. So I hope you like this video and my explanation. So if so, please give it a like, share with your friends, and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.